Hi guys, welcome to the second video of our series, which is also the second video of this particular section that we're dealing with. We are dealing in this section with Introduction to Programming. Now, in this video and all subsequent videos in this section, we will be focusing on learning a few fundamentals about computing as they relate to programming, so that we can be able to grasp a few things that will help us as we move along the way in our programming journey. It will be advantageous for you to grasp the concepts that we're going to be covering in these next couple of videos that are going to fill up the span or the rest of this particular section, the Introduction to Programming. In this particular video, we're going to be looking into binary, the language of zeros and ones, which is the only language that computers are able to understand directly. Right. So computer programming is all about giving computers instructions. So basically, you're telling computers what you want them to do. So when we give computers instructions, or when these instructions are grouped together so that they are able to perform a specific task or a group of related tasks, this grouping is what we then call a computer program. So a computer program can be considered as a complete set of computer instructions that are then that when they come together, they are then able to tell a computer how to perform a specific task or a group of specific tasks. To give a computer these instructions, we use programming languages. Now, there are many programming languages out there, such as C, C++, Java, Python, JavaScript, PHP, etc. Now, in as much as there are many programming languages out there, there's actually only just one programming language or one language that a computer is able to understand directly, namely binary. Now, one may wonder, what is binary? Well, in simple terms, binary is a number system that consists of just zeros and ones. So, a normal number system, decimal number system consists of 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary consists of just only two, 0 and 1. Or another way of looking at it, in the same way that our alphabets, the English alphabets, consist of 26 letters, A, B, C through to Z, binary is a language that consists of just two alphabets, 0 and 1. So everything that is to be expressed in binary is a combination or a sequence of these zeros and ones. Everything. One may wonder, why binary? Why is it that computers speak natively, or the language that they directly understand or understand directly is a bunch of zeros and ones? In order for us to understand why it is that the language of the computer, the native language of the computer, is binary or a bunch of zeros and ones, we would have to look at the physical or the hardware of the computer, specifically the memory of the computer, where these instructions and the data, whether it be images or it be words or it be videos or whatever the case may be, the data upon which these instructions are carried out upon, we would need to look to see how it is actually represented physically on the computer. When we look into this, which we are going to do in a moment, it'll become very apparent why it is that the computer understands only just zeros and ones at the very fundamental level. Let's look at two types of computer memory: the hard drive memory, or simply the hard drive, and the random access memory, or as commonly known, the RAM. Let's start with the hard drive. The hard drive is where the computer stores things permanently, until of course they are intentionally deleted or edited. It consists of many small cells which can be magnetized individually, either to a north or to a south magnetic value. We know magnets, they have a south side and a north side. So the disk of the hard drive can be individually on a cellular level be magnetized to either north or a south value. These individual cells, therefore, each of them represents a unit of data. Oh, by the way, these units of data, these zeros and ones, a single unit is called a bit. So the cells in the hard drive, an individual cell, by being able to be magnetized either to one of two values, namely a north or a south magnetization. Is that the word? I think that's the word. I'm not sure. Either to a north or a south value, then effectively it is then able to be used to store a 0 south or a 1 north. Next, let's consider the RAM. The RAM is where the computer stores programs that are currently running. So in other words, if for instance you open a Word, or you open a audio file, you're listening to some music or you're playing a video, all of those are stored in RAM while they are running. So even when you're editing a document, while you're working on that document, it's running on RAM. And then at the moment that you press save, it would then be persisted or stored more permanently in the hard drive. RAM consists of small memory cells similar to a hard drive, which can store an either or value. These cells are made up of two electronic devices, or two electronic components actually. A capacitor working hand in hand with a transistor. Now the capacitor is able to store a charge, or it can be without a charge. And the state of it having either a charge or not a charge is what then allows it to either represent a 0 when it does not have a charge, or a 1 when it has a charge stored in it. The capacitor will lose its charge over time, or it loses its charge over time, and as a result, it requires an external circuit, that is to say, external to the RAM itself, to consistently go over all of the memory blocks or the memory cells, checking what the current state is, checking whether there's a charge, if there's no charge. If there's a charge which has begun to decrease, then that charge has to be refreshed again. So in other words, because of this, unless there is constant current that goes through each cell and recharging or refreshing each cell that contains a charge, that is to say each cell which represents a 1, unless that constantly happens, then the memory in the RAM will be lost. It's for this reason why RAM memory is compared to short-term memory. And again, for this very same reason, this is why the moment that let's say your computer runs out of power or somehow shuts down, and whatever was currently running in the RAM that was not saved or persisted in the hard drive, it will be lost. So that's why, for instance, if you're working on a document, remember we said everything that runs, that's currently running, it runs on RAM. That's what RAM is there for. It's there for every application, whether you're playing a game, you're listening to a song, you're playing a video, you're editing a file, whatever the case may be, all of that is happening in the RAM. And RAM is the type of memory that is called a volatile. In other words, it can easily be lost. It requires a constant flow of current in order for it to retain the memory that it has, or to retain that pattern of the specific pattern of zeros and ones, which represent the current state of whatever program is running on it. That's why if you don't save a document, so when you do computer literacy 101, you're always told that when you're working on a document, you have to save it. Underneath the bonnet, what actually happens is that if you have not saved it and then current goes off, then there's no current to quickly refresh all of those capacitors before they lose that charge. Then the memory that was in the RAM is completely lost, and there's nothing that you can do about it. Unless, of course, for instance, nowadays programs, for instance, take Word, they have this functionality that's inbuilt whereby they automatically save a periodic backup of the files in the hard drive without you necessarily having to press save. So that's the only way that you could potentially be able to recover the file. So that in a nutshell is how RAM works. What should then become apparent to us now is that for both RAM and the hard drive, or in other words, for both the short-term memory and the hard-term memory, data is stored as physical cells or units, with each having an either or value, which is a representation of a 0 or a 1. In other words, the computer at the physical level, it has building blocks that can contain a value that is either this or that. Whether that be the case of the hard drive with its cells being magnetized to a north or a south, which with the norths representing the ones and the souths plural representing the zeros, whether that's the case, or whether it be the RAM with its memory cells or its tiny building blocks having either a charge representing a 1 or not having a charge representing a 0. So the computer at its physical level, at its very cellular level, if you'd like, has building blocks that can contain one of two values. It's for this reason why the computer therefore can only speak in either ors, or in Boolean terms, or in binary, or if you like, digital. That's what digital is, by the way, signals that are zeros and ones, or a system that speaks of zeros and ones. That is the language that the computer understands, because physically, the physical components that make it up, or at least that make up its memory, where all its instructions, all its data, and all of these things reside, they are constrained to either this or that at the cellular level. That's the reason why we then speak of the computer speaking of zeros and ones, or only understanding zeros and ones, or only understanding binary. Next up, we'll then look to see how we move from this binary to things that make a little bit more sense to us as human beings. Because, I mean, come on, who understands ones and zeros? We don't think in ones and zeros. So obviously something needs to happen that moves us from the ones and zeros to things that we're familiar with. For instance, images, videos, etc. And by the way, we'll also answer the question of, as a programmer, then does that mean that you have to memorize ones and zeros in order for you to be able to program or to write a computer program or to instruct a computer? Those are the things that we'll be looking into in our next video. Don't forget to subscribe so that you do not miss any of our tutorials, because you snooze, you lose. Later.